Okay, it's now 6:50. Welcome everyone to the Chinese Institute of Engineers, San Francisco Bay Area chapter. Um, we'll always go through the introduction slides, so this time is no different. Um, as you know, the CIE USA San Francisco Bay chapter is full of heritage. It was founded in Cornell University by Zhan Tianyou, a famous railway engineer who pretty much built lots of the early American West Coast railway systems, who was engineer, and he founded the first CIE chapter in 1917. The San Francisco Bay Area chapter was founded in 1979, which is almost around 45 years ago, and we're still going strong. And we have activities like today to basically promote the core values of the CIE organization. We're a nonprofit organization serving engineers, scientists, and students in the greater San Francisco Bay Area community. We talk about technological advancement. We provide opportunities for networking and communications among engineers with different career paths. We do have great opportunities to network and meet with the industry leaders. In the previous events, we do end up having a chance to invite the NVIDIA CEO to be part of the talks, and the CEO of AT&T, Annie Chow. And as you know, the recent GTC event at NVIDIA was a very proud moment for the Bay Area as a whole, since Jensen was the leader of NVIDIA and has a huge influence in the world with NVIDIA's contributions to AI. We do have virtual capabilities like we're doing right now. Since COVID, from 2021 to 2022, it was full virtual, and we were still able to hold seminars and talks from various industry leaders. We do have many opportunities for conferences, and we do have an annual conference, which happens around April and May timeframe. We're proudly sponsored and generously sponsored by lots of industry leading companies, such as TSMC and the rest of the companies listed here. There are subgroups in the San Francisco Bay Area chapter of CIE, mostly involving technology engineering. There's the emerging technology group, the electrical engineering and computer science, EECS group, electronic design technology, and biomedical engineering group. And plus we have the Young CIE group, which sponsors activities for young people for more networking opportunities. And if you're interested, there are many ways for us to get involved. Here are the QR codes on your screen, and also in the audience that you can scan to get connected via various ways. And for receiving regular CIE newsletters, you can sign up through this QR code as well, so that you will have notifications for latest webinars. For example, last week we invited one of the startup founders of Fanta Field from a PhD student from UC Berkeley, who was founded by and advised and guided by Chongming Hu, who invented the FinFET technology, and the CTO of TSMC. So we have various events that are very exciting, and there are various ways we can get connected through people and exciting emerging technologies that done by people in the San Francisco Bay Area with Chinese heritage in particular. So without further ado, I will invite Dr. William Cao to stage and take over screen. He received his BSCE, MSCE, and PhD from University of Illinois, Urbana-Champaign. He worked on semiconductor and electronics design automation for a long time, with holding several senior executive engineering management positions in the past, such as Texas Instruments, Xerox Corporation, and Cadence Design Systems, which is a very, very important tool in the industry. So without further ado, I will invite Dr. William Cao to the stage, and everyone have a great seminar. Yes. Let's see.
We'll go back one slide. Okay, okay. And then, not the part. Okay, very good.
Okay, thank you. Yeah.
Thank you, Fonray, for the introduction. Welcome everybody here, physically here, and there are a lot of other people virtually online. Right. So right now we live in a hybrid world where half of it is physical, half of it is virtual. So welcome everyone to tonight's seminar. The talk tonight is going to be called Transformative Technologies. Okay, so this is tonight's agenda for the talk. First, I'm going to start with the introduction of what are transformative technologies. And tonight we'll focus on 5 technologies. So tonight's talk, actually, because I've been giving recently a lot of talks on AI. So myself, I got tired a little bit. So I said, in tonight's seminar, I'm not going to talk too much about AI. Next month, if you're interested in AI, I talk about all the details about AI, okay? But that will be my last slide to introduce April's talk. So tonight's talk will be focusing on number 1, satellite communications. Okay, everybody knows about Starlink and things like that. Ambient IoT, Internet of Things, secure computation, digital humans. A friend of mine just recently sent me an email. What is a digital twin? Okay, so tonight we'll be talking about a lot of these virtual entities. Okay. The other thing is autonomic and adaptive robots and drones. So these days, a lot of things are no longer pre-programmed. That means that they can think for themselves and they can learn new things. Okay, so those are adaptive and autonomic machines. So those are the top 5 I'll be covering in tonight's talk. And then there's 5 more that I just mentioned. Those are the next 5 are more like maybe more futuristic, like things like advanced computing, quantum computing, and so on. New materials like graphene. And then I'll do a summary and conclusion. Okay. So what are transformative technologies? Okay. As the word implies, it's going to imply a big transformation, and also it's going to have a big impact on society in the way we live, we work, and we interact. Okay, so they're going to bring a lot of change. They're going to increase the productivity. They are going to talk about, for example, make improvements in the quality of life and address some global challenges. Now, with every technology, there's also some liability. So we need to make sure that the regulations, the ethics, and so on, are able to catch up with the speed of the technological improvement. Okay, so those are the things that need to be watched for. So let's dive in a little bit more about transformative technologies. We can roughly group them into basic transformation, intermediate transformation, and more advanced transformation. So, and also if you look at these concentric circles here, the inner loop is called more reactive. It's just something happens, you react to it, okay? The next one, intermediate, is more strategic. They're thinking a little bit more longer term, okay? And then the ones that have the most impact are the innovative technologies that really people have not experienced before. Okay, so in this chart, you see a lot of technologies that I've talked over given seminars throughout the years. I've been given, I retired about 10, 15 years ago. And then I've been giving seminars almost on a monthly basis. So all the topics that you see on this screen, I've probably given a seminar before. Okay, IoT, cloud, virtual, AR, VR, robotics, blockchain, self-driving vehicles, Right now, most of the talks that I've given recently have been focusing on AI and robotics. Okay. So these are the ones that if you look at it, say, if you name the top 5 or 6 transformative technologies that everybody is already aware, they're all listed here. Okay. You have AI, you have autonomous vehicles. Okay. You have blockchain for more the fintech side of things, financial transactions. The IoT that we'll be covering a little bit tonight, although today I'll focus more on the tiny ambient IoT. IoT is very large domain. Okay, I'll start with that and then narrow down into ambient IoT. Smart cities and fintech. So most of this I've given talk already before in the past. Very quickly, I'll mention about fintech because most of my talks have been focusing more on the IT side. Okay, the physics and mathematics of things. I've dealt less on the financial side. So fintech is something that I've given a talk before. And if you look at this slide, you're going to see things that you have heard about. For instance, blockchain. Blockchain is a technology that secures transactions. Okay, it's more distributed. Okay, instead of centralized bank, everything is distributed. Many people have copies of it, so you cannot fake it. Also, you can track all the history from the inception to the current state. Okay, so you have digital money. You have also cryptocurrency. Also, everybody probably have heard about crowdfunding. If you're looking for funding and say, well, you don't want to go and ask for a loan, you can ask people to donate money. Okay, so all of that is part of fintech. Okay, financial technology or technology related to financial side of it. Okay, so in tonight's talk, these are the 5 areas that I'll cover mainly today. Number 1, satellite communications. Everybody heard about Starlink, right? Elon Musk has a company that has the satellite communications. I'll cover in more detail what satellite communications are and what is it good for. Okay. Then we'll cover tiny ambient IoT. The third one is secure computation. So everybody right now is focusing on computation. And a lot of the times you need to share the data between many parties. So how do you guarantee the data security and privacy of the data? So you don't let people can work with your data, but they don't have really access to look at the inside, okay, your private information. Okay, another one is the digital humans. We'll cover many different versions of digital humans, from avatars to digital twins and so on, okay? And then last but not least, we'll cover adaptive and autonomic drones and robots. So we're talking about machines that no longer need to be pre-programmed. That means they can work and by themselves. Okay, so they're autonomic. That means they're independent. It's not like you have a human remotely controlling the robot or the drone. Okay, so today everybody knows about drones. For instance, even in the Soviet and the Ukraine war, you use a lot of drones. Well, all those drones are controlled by other people remotely. Okay, but now we're moving to self-control. Okay. Also, the other thing is that they're adaptive. That means that they can learn by themselves. You don't need to pre-program everything, but the machines can learn by themselves interactively by talking to the consumer or to whoever you're interacting with. Okay, so these are the 5 areas that will be the focus for tonight's talk. So let's start with satellite communications. So everybody is exposed to daily communications. Everybody has a phone. right? You have a cell phone, you have at home, you have a land phone, you have internet, you have your PC, right? But there are a lot of subsets of people that cannot be covered. For example, if you're in the middle of the ocean, unless you are in the ship, if you're by yourself in a dingy boat, you have no communications with anybody. Okay, you cannot even ask for help, right? Because there's no communications. If you're even taking a walk and taking a hike in the mountains, and you don't have a cell phone, or there's no relay stations in that area, you cannot communicate with anybody, right? Why? Because there are no relay stations. There's no substations that can transmit the information for you. So what happens? Then that's where satellite communication is good, because on the outside of the planet Earth, there's the space, and you can have satellite. So even though you cannot have a physical relay station, you can communicate above with a satellite. And then through the satellite, you communicate with everybody else. Okay, so so in areas that are rural, so if you have a farm and it's sitting in the middle of nowhere, there's no really a lot of stations or electric, that they're nearby. How do you communicate with people? If you're in mountains, or you're in the middle of the ocean, okay? So that's where satellite communications are for, because there's a way that you can communicate above and then to everybody else. So one of the ones that, for instance, Starlink is a LEO. LEO is the low Earth orbit. That means that there are many orbits. We have the planet Earth, and the outside the planet, depending on the distance from the satellite or from the communications entity, how high above the planet it is. You have different orbits. Okay, so I'll show you later on in a picture what LEO and GEO and so on are. Okay, so what's the benefit of LEO? Low Earth orbit. That means that it's not too far away from Earth. So one of the things that people are really concerned about is the latency, is the response time. Is that when you're putting a request to either a internet and you ask for information, how fast does it get back to you? That's called response. That's called latency. Latency means the time that it takes for you to make the request to the time that you get the answer back. That's called latency. So everybody's looking for low latency. For example, why is it that right now self-driving cars are not completely autonomous yet? It's because the latency is not there yet. So when the self-driving car is in the city and somebody steps down the sidewalk and then right in front of the car cannot send the message and get the reaction, what to do in the nick of time. So the response times have to be under so many seconds, because otherwise you already ran over the person. Okay, so that is why the latency is very, very important these days. Okay, so a picture is 1,000 words. Okay, so take a look at this picture. So there are various kinds of orbits. That means that the orbit is defined from how far you are from the surface of the Earth. Okay, so the lowest one is called LEO, low Earth orbit. So those are like 330 miles above the surface of the Earth. Okay, while the GEO, which is like the one here, you see here on the upper left corner, is like 22,000 miles away from the planet. Okay, so what are the pros and cons of each? In the LEO, you are very close to the surface, so your response time is fast. Okay, but on the other hand, because you are so close to the surface, you need many of the satellites, because you cover only what depending if it's a low altitude, you can only cover a small area. While the further away you are, like for instance, the ones that are really far away, you with one satellite, you can cover the whole planet. Okay, so the difference is in the number of satellites that you need, and also the response time and how far away you are from the planet. Okay, so that's, now I've also listed here some of the various companies that are operating in the very different orbits. Okay, so the ones that everybody hear about, you know, Elon Musk, Starlink, well, that's LEO. And that's the reason why every few months, Elon is sending satellites to the space, because you need a lot of them to cover the entire planet. Okay. So Starlink, Kuiper is the one from Amazon. Okay, and so on. And then there's one that is from Britain. GPS, that's another one that we all are familiar. We all use GPS, right? Global Positioning System. Okay, that's a MEO, that's middle range. Okay, and then GEO, there's a Viasat and HughesNet. Those are companies that are operating higher above the planet, but they require less number of satellites. Maybe one or two is enough to cover the whole planet. While in the LEO, you need thousands of satellites, okay? Because they cover only, they are very low altitude, so you only cover over a very small space. So let me go to the next slide, and then I'll come back to this one. Okay, this is just, again, a picture is 1,000 words. So take a look at this picture. On the upper left corner, you see like a constellation of satellites. Because as I say, in LEO, you need a lot of satellites to cover the entire surface of the planet, okay? And the distance between satellite to the next satellite is not that far away, okay? So you can see that the whole planet is covered by this network of satellites, okay? On the upper right corner, you see one of the satellites out of the thousands of satellites that are circling, navigating around the planet, okay? And just to show the proximity of the satellites, at night on the lower right corner of your screen, you see like a chain or a link of these satellites. When you actually see the light feedback, you see there's a like dots, okay? There, each of them is like a satellite, okay? So that gives you the concept about the satellite. So let me go back to the previous one. So this one is sort of like the whole idea about how satellite communications work. On the top, you see that, as I said, there's a network of satellites. So between satellites, you have to also have communication, okay, between satellites. So that's called inter-satellite communications. And then, of course, you have from the ground, you send a signal to the satellite, and it bounces from the satellite, and it comes back. And either the information goes from the ground to the satellite, from the satellite to another satellite, okay? And then maybe on the other side of the Earth, the signal comes back from the satellite down to Earth. Okay, so anyway, that's the way the concept of the thing is. So on the ground, you have ground stations that send signals as well as receive signals. Okay, and then so the thing is actually quite complicated. I've given seminars just, by the way, all the topics I've given or I'm presenting tonight, I've given seminars standalone. So satellite communication, I can talk for at least 1 hour, 2 hours, just on all the details. But tonight, that's not the purpose. Tonight is just to give you a more global coverage. Okay, so if you want to listen to a specific talk on satellite communications, there may be already some recordings I've given you in the last year or so. Just everything was done in the probably last couple of years. Okay, so I've been giving like talks almost every month. So, okay, so this is the idea about satellite communications. Okay, so what are the opportunities for satellite? Anything related to communications is gain. Okay, so you have from smartphones. If you have a smartphone and you're in the middle of a mountain, and there's no nearby stations. Well, if you have a link from your phone to the satellite, maybe you can reach somebody, right? Broadband, okay? And also the other thing that is more and more important, and I also cover on another separate topic, is IoT. IoT stands for Internet of Things. There's more and more devices. You know, we all individual, each of us, we started with a cell phone. Everybody said, okay, well, I have a cell phone, you have a cell phone. Okay, now there's a smart watch. There's a smart glasses. Okay, so before it was like one-to-one, one device per person. Okay, they forecast in the next few years, there will be up to 6 devices per person. Okay, so you have, you know, a lot of people are already wearing the what they call it, Fitbit or whatever. Say, okay, well, I measure how many steps I have. That's another device. There's a lot of devices. Okay, a lot of applications that monitor your heart rate. Okay, things like that. Okay, so there'll be more and more. So in the future, it will be almost, they predict that will be 6-to-1, 6 devices per person. Okay, and all of that require communications. Okay, so that's, let me just say, sort of like a philosophical observation. You know, with all the technology, whenever there's a natural disaster, nothing works. Okay, because we're relying too much on technology. It's like, oh, well, everybody has a cell phone. Well, when there's a big earthquake, there's nothing. You cannot talk to anybody because all the relay stations are down. Okay, so if you're in the middle of something, and then you're in the middle of the building, and then all the electricity goes out, the elevators don't work. There's no light, nothing works. So on one side, we're counting on technology to help us. But on the other side, it's also, we have more and more dependent on it. And that's also dangerous. Because when nothing works, then you're stuck. Okay, so anyway, that's a side observation. Okay, so future directions and challenges. So one of the challenges is that there are more and more providers. So for instance, even the satellite communications, it's not just only Starlink. From the signals from, let's say, on your own at home, you can have different internet subscribers. You can, you know, you don't need to always use the, as a matter of fact, today, very few people are using Starlink. Right, because, but everybody is relying on some, you know, AT&T or, you know, whatever telecommunications, Verizon and so on, right? So there's more and more providers. And with more and more providers, one of the problems is standardization becomes also a problem. If you use something or it works only with this vendor, but it doesn't work, if you change the vendor, it no longer works. Okay, so the other thing is that, as I show, each of these companies, they have to launch so many satellites. And that's the reason where SpaceX is making a ton of money, because everybody who needs to send them a satellite to orbit relies on Elon Musk, SpaceX, to send the satellite to the space. Okay, so why does Elon Musk make money? Because he invented a reusable rocket. Before, every time you need to send something, you send the thing, and then the rocket, you know, that's it. It falls into the ocean, that's it. You can use it only once. Why does Elon Musk make money? Because he can send the satellite via a rocket. And then when the rocket comes back down, they can recapture it and they can reuse it next time. So look at the savings, right? So anyway, there's a lot more that you can read. By the way, if a lot of people ask me, oh, can you share some of the slides? Usually my philosophy has always been uniform, except for last month's talk where it was like mostly in demand skills. I said, you ask me, I'll send you the whole pack. In most of the seminars that I give, there's a lot of IP because a lot of the material that you see here, they're all available. If you go and search in the internet, you probably can find a lot of material that I put together. Okay, but that also takes a lot of time. So that's my personal IP. I'd be very glad to share with you any subset of it because nothing here is classified. Everything is available. But I don't want to give my entire card deck, okay, because it took me usually it takes me about several weeks to put together a presentation. Okay, so usually my talks are 40, 50 slides. Okay, so, but if you say, oh, I'm really interested in the IoT thing, I'll be glad to send you all the slides on IoT. There's nothing that I cannot share, but I don't want to give you the whole deck and then, because it takes a lot of time to do it. Okay. So that's the first topic. It's a satellite communications. I already covered why we need it, why is it important, why is it useful. Second topic is ambient IoT. Okay, first let's start with what's IoT. Okay, Internet of Things. We're saying that I already mentioned that each of us will have more and more devices. And everything that we see around us, from the refrigerator at home, to the thermostat, to the toaster, okay, to your car, to your phone, to your glasses, to the cow in the farm, everything has an ID. And you can cover from thing to thing. Okay. So with IoT, you can go to a restaurant and you can order a steak. And they can tell you where was that cow raised, in what farm, and how did it go through from the farm to the grocery store, from the grocery store to your refrigerator. Okay, because everything will be labeled and you can track everything. Okay, that's Internet of Things. Everything is a thing, including humans, including animals, including a table, a chair, everything is a thing. Okay, and then there will be things that you can interact with each other. Now, what is tiny ambient IoT? So let's zoom in into what is a tiny ambient. So with more and more devices, one of the things that people worry about is that, for instance, every time you have a cell phone, at night you have to charge it. Okay, so how long does your cell phone work? Depends when your battery in your cell phone goes out, right? So one thing that is very important is the power. Okay, and then the smaller your device, also the cost goes down. So tiny ambient, just to define, is that, read the first line, okay? You have a large number of objects because everything is a thing. Very large number of devices. They're all interconnected to each other. They can communicate to each other. They also have sensors, okay? And the more things there are, the problem is that communications between devices that are being fabricated by different companies. So is there a standardization? Is there a regulation to communicate from your refrigerator to your toaster, from your cell phone to your home? Otherwise, they're all disjoint. Right now, today, most of the things are still disjoint. Okay, but in the future, everything will be interconnected. So when you go before you go home, you check your cell phone. You know what is inside your refrigerator. I said, before I head home, I need to go and buy a box of eggs. Okay, my green onions is also running low. Okay, it will take a whole inventory of what is in your refrigerator because everything has a tag and everything will be tracked and you will know. We're not there yet, okay? But that's, for instance, part of what a smart home is. Smart home is that from your cell phone, you can control before you head back home. If you're in the summer, say, turn on the air condition half an hour before I get home. Okay. And then right now, while I wait, shut down all the lights. Okay. When do you turn on your washer? Okay, because right now, PG&E is like, they have rates, right? Depending on the hour, they charge you a different amount of money. Okay, so all of that you can control. Okay, so anyway, this is the big picture. Hopefully everybody in the audience can see all my slides, clear. It's almost like sitting in front of your PC, right? Okay, so if you look at the IoT, in the inner circle, you have the people, okay? I'm talking to you via my cell phone, okay? Between people. The outer one, then you have, that's number one, right? Number two is devices. So each of us has many devices. You have a cell phone, you have a smart watch, you have your gadget that tells you how many steps do you take today, right? All that, those are devices. Then the third one is networks, okay? So you have the internet, you have the things that you belong to, all the chat groups that you belong to and so on. And then the last one is called the space. It's like at work, in the hospital, in school, right? There are different things. So different levels, okay? But everything, there's all devices everywhere. And then on the outside, you have farms and then you have the county, the country, and then the whole planet. Okay, so IoT, when I used to give the talks on IoT, it covers everything. So you can see there's not a thing that is not covered under IoT. Smart cities, traffic lights, temperature in the city, stoplights, traffic, right? Water, utilities, all of that is part of smart cities. Energy management, utilities, the cost of the electricity, wearables. That's something that now we wear a jacket. The jacket can have, you can even show a picture on your jacket. That's called the wearables. Home appliances, agriculture, what's happening at farm, the food that you get, that you eat and get to your grocery store. Cars can, in the future, cars will talk to cars. Cars will talk to the surface, the stoplights, and so on, okay? Manufacturing, transportation, healthcare, smart homes within your own home. Okay, so all of that is IoT. So right now, the one that we're focusing right now, the tiny ambient IoT, it has the following characteristics. Low power, because think about it, on different, if you're in the home, you use different amount of power. If you are just talking about your cell phone, you don't need as much power. And how long does the power last? That's another thing, okay? No, but some of them will be not using even no batteries. Some of them will be even disposable, okay? A small example. Right now, for instance, when you take some pills or whatever things you take, when it gets into your body, it will dissolve after it's finished. So you no longer say, oh, well, I swallow something, you have to go and fetch the whatever is left. They just dissolve into your body, okay? So physically small. So we're saying that IoT is all encompassing, from very large to very tiny. So here we're talking about the tiny. Small physically, low power, okay? New ways to manufacturing the small things. And because it's small and so on, it's low cost, okay? Because IoT can be very large, from a refrigerator to a car, everything is a device. Here we're talking about small things. Okay, so here I even have some extreme cases where it says, for instance, everything in order to capture the information, because there are such a large volume of things. everything has a sensor to capture the information or data from that particular device. So here is a sensor attached to a butterfly. This is sort of exaggeration, but that means that any small thing, even a fly, maybe it has something attached to it. It will track where the fly is. Okay. Okay. So because if it's tiny, low power, you can afford to do it. So so this is the thing that I was talking about: biodegradable things, electronics or whatever. So once you inherit that, you don't have to worry about how to take it out. Okay, so this is a category of IoT that's really tiny and ambient. Okay, so challenges, well, whenever it's a small and it's resides physically on your body, you have to worry about privacy. You have to make sure that, you know, you have wearing a lot of wearables and everybody can track you where you are. So, oh, this guy right now is sitting in the E-Trick seminar room. I mean, right now everybody is already doing that. Say they can track where your cell phone is, and then say, okay, well, you know where you are. Okay. Okay. The other thing that it can, because there are so many things, also the waste that it creates is also an issue. Because think about it, everything, there's also some leftover. So when for instance, our cell phone, in my case, you know how many cell phones or past cell phones I have sitting in my drawers? Probably at least 5 or 6 phones that I used to use because I used to change every couple of years. You change the cell phone, and then once you remove the chip, the old one is just sitting there. Well, unless you're smart, you can sell it. But you know, I said forget it. You know, I'm not going to just make money on another old phone that nobody wants to buy. But everything you use, you're also creating waste, the e-waste. Right? Also, how do you regulate things? That's really tiny. You know, when the drones initially came out, one of the main problems that concerns they have is that how do you regulate the drones? Because your neighbor is flying a drone into your patio. I say, oh, I know what Bill's patio has a, you know, grill, because the drone can fly over your fence and know exactly what your neighbors around you have. So how does the law protect the individuals about the data privacy and security? Okay, because nobody says, I don't want people to know that I have 1 dog and 2 cats, you know, in my backyard. Okay, so with any technology, you want to make sure that the entire society is moving along. Whenever you have a new device, you have new laws, new regulations. Okay, that's why people are worried about AI. Say, well, when AI is too powerful, how can I prevent AI to killing the humanity? Okay, so anyway, that's the thing. Okay, third topic, secure computation. I recently watched a YouTube video that's, I don't know where it's the Jensen one or somebody says that the future is just computation, computation, and computation, because he was trying to sell more GPUs. Okay, so to him, the whole world is computation. But the thing that you have to worry is that how secure is computation? Because you have a lot of very powerful machines, hardware. Okay, but again, all computation relies on what? Just one word: data. If you have no data, how can you compute anything? So how do you secure the data? And how do you maintain the privacy of the data? That's important. So secure computation. Very often, a lot of people, you want to do some transactions between multiple parties, you have to share some of your data. But when you share the data and people use that data, how do you prevent the other party to know that it's your personal data? You can share the data, but if people don't know it's yours, they're not invading your privacy. Okay, so I'll talk about a little bit about encryption and multiple party security. Okay, that's the reason why there's cryptography. Okay, so secure computation is basically how do you ensure the security and the privacy of the data, of your personal data. Okay, so secure computation, it has many things. Sometimes you have to trust somebody else, because otherwise, if you don't share the data, how can other companies or somebody else can help you? For instance, when you go to HR block to have somebody do your taxes for you, if you don't pass on the information, how can they work on it? So you have to pass on you have to share some of your data. But how do you guarantee that data is not given up to somebody else? Okay, you have to trust, right? The other thing is that if you see another trend is that everything used to be centralized. So when you go to a bank, okay, you put everything in one, you go to Bank of America, so okay, you have. Okay, now more and more information like the blockchain and so on is that there are multiple parties. All the information is distributed. The environment is not distributed. It's no longer just centralized. So it's distributed, decentralized, and shared. Okay. So how can you let another party operate on your data without losing the information that comes from you? Okay, so a couple of things. So these are the two main components about secure computation. The first one is that everybody heard about encryption. Okay, like cryptocurrency. People will say, okay, well, in order to mine Bitcoin, you have to spend a lot of compute power so you can say, okay, I've mined the data and it belongs to me. Well, and then why is everything so secure? Because it's encrypted. But whenever you have encryption, you have to, one way is to encrypt it, the other one is to decrypt it in order for you to do it. So people have thought about ways is that how do you change that model? Or you can work on encrypted data. So I'll talk a little bit about homomorphic encryption. Okay. The other one is when you have more than one party. So if it's beside you and the bank, somebody else wants to know also information. How do you ensure that now the parties involved, somebody divulged something? Okay, how do you guarantee multi-party computation? That's the other one. Okay. One is the encryption. That is that how do you use technology to not let everybody have access to it? The other one is to how do you make guarantee that whenever it's a shared data, your personal information, people say, well, I know there are 100 people in our bank using our services, but you don't let people know who is who, how much does the individual have. Okay, so you can make the data so that it's not personal. Okay, so homomorphic encryption. So that means that you can operate the data without having to decrypt. So all the information, whenever we send the information, for instance, through when you buy something and you give Amazon your credit card number, okay, so that other people cannot get access to your thing. All the data, when the thing is sent between you and Amazon and all the stuff, is encrypted. Okay. Now, the thing is that how can you allow somebody to work on data that has not been decrypted? So that's one way. So that's called homomorphic. Homo means the same. Okay, same form, homomorphic. Homo is the same, morphic is the form. Okay, so anyway, I've given talks just on this topic for 1 hour, so I don't have the time to give a in-depth talk about each technology. Okay, so you have to wait for whenever this topic comes up. So the other one is multi-party. When you have multiple party, and you have to share the data because otherwise other people cannot work on the data. if you don't share your portion of it. Okay. But how do you ensure privacy and correctness? And how can you prevent one of the parties to divulge or your information? Okay, so that's SMPC, Secure Multi-Party Computation. And behind each of these technologies, there's a way that they do it. Okay, so today I don't have the time to dive into each of these silos in detail. So whenever I talk about this subject that will be covered nothing but this, then you can talk about all the algorithms and all the ways that they do it. Okay. So who are the people who have to rely on secure computation? Okay. So you have, every time you have a, where's a healthcare, a home or things, everybody needs data. Right now, we have moved from the data, from the era of oil is the main staple to data. We're living in the world of data. Data is the new oil. That's what they call it, right? So every time you share the data, but before you go to a gas station, just buy your own oil and that's it. But now you have data. And the good thing that data is that it's electronic and you can work on it. But the danger is that you're afraid that data can fall into the wrong hands. Okay. So let me see, where am I? I'm doing fine. And I will end my talk at 8 o'clock sharp. Okay, so my talk usually goes for exactly 1 hour, 7 to 8 o'clock. So here are some of the technologies we mentioned about homomorphic encryption. Okay, there's more and more this word that you're going to hear a lot more, accelerator chips. Because right now things work so fast, you need to have accelerator. Why is it that NVIDIA is making so much money? Because they have GPUs. GPUs are accelerated chips for AI computing. AI requires a certain number of operations, like matrix multiplication in order to handle images and so on. And the GPUs are especially good to operate on a parallel way with the data. So people use GPUs instead of CPUs for AI computations. Okay. So I'm going to skip a lot rest of it. But if you are interested in any of these slides, send me an email. Say, Bill, could you send me your slides on secure computation? I'll share all the slides with you, and then you can digest them on your own. So don't count that I'm going to go over every single bullet of every slide, because I have about 40, 50 slides. That means in 1 hour, I'm covering at the rate of 1 slide per minute. Okay. Now, some people give presentations, they have only 7 slides for the whole hour. Okay. But everybody does it a different way. Okay. New topic, digital humans. So right now, we're living in a bipolar world. There's the real physical thing, and then there's the virtual thing. Okay, so whenever people ask me what is the digital twin, so we are a physical being, and there's a digital twin in the future that is also built up. That digital twin will have all the information that is related to me. That they, for instance, if it's economic or financial data, my digital twin will all have all the information related to me. Okay, so it's not a physical entity, it's a virtual thing. But in order to operate, they have all the information about Bill Gahl. So that's why it's a twin. It's not a physical being, it's a virtual thing. Okay, but it can represent you. So in the manufacturing is the following example. You have a fabrication line where you have a series of 10 machines that you put in the material, and on the other side comes out a chip. In the middle, you have 10 machines that each of them does a different operation. So one day it says, well, there's a new machine that does this function number 7 better than the current one. So we want to replace the current machine with a new machine. Well, how do you test that that will work? You put in the digital twin of that new equipment in lieu of the current. It will still work. It's not physical yet because the new machine hasn't arrived yet. But you perform the function of the machine. So that's a virtual entity, but it's a twin of the physical machine. And it can stand in for the physical. Okay? So today we're hearing more and more. So today I'm going to talk about digital human. That means the digital version of you. Okay? Or with a person that you may not know, but it's a digital representation. So guess what? In the future, let's say you want to buy a sweater, but you don't have time to go yourself. Okay? You can have the digital twin go and try the sweater. Oh, does the digital twin will know what colors you like? What is the size that you wear? Okay, all that information, the digital twin will have that information. Okay, so let's say you go to a meeting and say, well, sorry, I cannot make it to the meeting. The meeting is in Dubai. And they have another meeting in Paris that week. So I cannot attend. So I send my digital avatar to the meeting. Okay, it's a virtual copy of me. But in order to attend that meeting, my clone or my digital twin will have all the information, just like if I were present. Because if I'm going to talk about, say, energy in that meeting, my digital twin will have all the information about the subject that I'm going to be, if I were physically present. Okay, now that's maybe a subset. That digital twin to participate in an energy meeting doesn't need to know how much money I have in the bank, right? That's not relevant. If you are participating in an energy conference, all the knowledge and all the opinions that I have related to energy will be available in the digital twin. But other information that I don't want to share, it doesn't have to have it. Okay? So there are many kinds of digital humans, and I'll show you a picture of what different is. They can range right now. The hottest thing right now is called humanoid robots. Okay. So that's a digital human. Okay. Now the robot can be, you can make a robot that has your information. Now, for instance, right now, people have LLMs. LLMs is all the newest, latest, language-based information. So if I eventually one day they'll capture all the content of my brain and put it into a robot. Say, okay, this is a Bill Gates version of the robot. He'll know everything that Bill knows. Okay, so right now it's a very generic thing. Okay. Okay, so, well, let me go to the next slide. That will show a little bit better. So here are the different, because you probably heard about different terminology. You heard about avatars. Avatars is a virtual copy of you. It may look, you can design it so that it looks like your face, or it can look like a cartoon. Just like, for instance, in WeChat, everybody has a symbol, right? So it represents me. Like mine is like a yin-yang symbol. Okay, another person may say, I choose a flower, a pretty flower, to be my representation, right? So an avatar is really up to the owner. Says, what do I want my avatar to look like? I can make it like Superman, even though it sort of represents me, but it looks like Superman, okay, with a big S, okay? So that's that. Human and robot, that's also a digital human. Okay, why are humanoid robots right now the most hottest item right now is because they are trying to make before it used to be machines that don't look like human. For instance, in the Tesla factory, they have a lot of robots that perform a certain function, install a door or paint a car, but they just have to be a machine. They don't have to look like with one head, two arms, and two legs. Okay, right now there's advantages of making the robots look like humans because they can perform better in society. Because when we go home, and for instance, in my home, I have a stairs. If the machine doesn't look like a robot, it cannot climb the stairs. If it has only wheels, you rotate it, you can roll around. For instance, the most typical example that we use at home, you have a Roomba. It vacuums your house. But the Roomba cannot climb the stairs. So you go to the second story, you have to carry your Roomba upstairs, right? Well, if your robot who knows how to vacuum clean, it has two legs, it can by itself walk to the second floor and vacuum clean your second story and then your first story. So because our whole world is made according to the way that we function within society. Okay, we have two legs, we have two arms, okay, we have a head and so on. If you look at today's robots, by the way, I'm just sort of like digressing a little bit. There are different kinds of robots. Because right now, the emphasis is in the function that the robot performs. So if the robot is supposed to just help assemble a car, it doesn't have to have a head with the eyes and the nose and the mouth. You don't need to. Okay, it has some wheels that can move fast along the factory floor. It has two arms that can actually help install the car, but it doesn't have to look like it. But so it depends on the function. Okay, so right now there are different kinds of robots, and I expect in the future they also look different depending on the function that they're being asked to perform. Okay, digital twins, I already talked a little bit about that. Virtual assistant. Okay, this is probably the next thing that is going to come up is that it's going to have a humanoid robot that will be your companion. Whenever you go to a meeting, you can have a sidekick walking alongside you. It can function as a bodyguard, okay, because the robot can also help you defend you, okay. If you go and ask a certain thing that you don't know, just like today, you go to ChatGPT and ask the thing, well, you can just ask your digital robot, okay, because they will understand conversation. You don't need to go and type in your prompt, okay. Right now, that's what the latest humanoid robots that I'll be talking about next month. Your interaction is via voice. You talk to it, and the robot will be able to respond to you. And you don't need to do it via text. This is right now, that's what is called multimodal. Besides text, it can do video, audio, and so on. Okay? Digital humans, I think they are making them more and more look like humans. As a matter of fact, if you look at all the YouTubes, if you type in robot into a YouTube, it probably has at least 7 to 10 different kinds of robots. Robots in China, Figure, 01, the Optimus from Tesla, and so on. Okay, there's so many. Okay, I will condense all that material for you for next month. But that's another topic. Okay, so I'm going to skip. Why do we need digital humans? Just like why do we need robots? Because robots don't have to eat, they don't have to sleep, they don't get sick, they don't demand the race, right? That's why the machine can play chess for a whole day. We have to go and eat and rest and so on, right? And sometimes we get sick. Machines don't. Okay, so they're 24/7. So, and why are they important? Because we live in a world where we need to communicate. We need to communicate between people, between us and the organization. When we talk to another institution, when we talk along the phone, you have to communicate. And then sometimes if you're not able to do that, the digital human will be able to do in lieu of you. Okay? So before, when there were just LLMs, if you go and want to participate in a virtual meeting, how do you do that? Okay, with a digital human, the robot can actually voice it. So you tell them, okay, this is what I need you to say for me when I'm absent in the meeting. Okay, so these are some of the examples where you use digital humans. Okay, right now, for instance, a lot of jobs will be going away. When you go to a bank, you have a reception and say, okay, well, how can I help you? Okay, so, okay, well, I need to withdraw some money. Okay, so all those functions eventually will go away. So everything has a positive and negative side. On one side, there will be a lot of jobs, current jobs that will disappear. But there also at the same time, there are a lot of new jobs that today don't exist that will be created. So what we need to do is that we need to adapt. So say, okay, well, the bank teller, in the future, you probably don't need it. If you have a receptionist at the bank who just comes and says hello and they direct you to the right, person, you can have a robot do it. You can have the robot tell you all the benefits about that bank, what is good about it, how can you invest the money. All of that, you can have the robot do it. You don't need to have a person do it. Okay? To do cashier job, you don't need to have a person do it. So all those gradually will disappear. Okay? But there will be new jobs. So the thing is that as technology evolves, we need to evolve. We need to change. Okay? So we need to say, okay, well, I better also consider not doing the things I'm doing today. It's not like in the past, if you are a farmer, you're a farmer for life. Okay, your father was a farmer, you are a farmer, and then your son is a farmer. The world has changed. So you better be prepared to change yourself. So a virtual assistant works in finance sector, in healthcare sector, all that stuff. So let me just say a couple of words on healthcare. A lot of the people who are manning the assistants, some of those jobs will go away. But there will be new jobs that because you have AI, you need to have people who understand. So you need to evolve. It doesn't mean that you have to get out of that business, but your role is going to be changing. Okay, you need to be able to read graphs, okay, or pictures. Whenever you do a scan, okay, you can. How do you understand it? How do you make sense of the data? Okay. So here are again examples of where digital humans will be. Customer service, you'll be replaced by digital humans. Okay. Training people, teaching some subjects, you'll be done by robots. Because it's just a repetitive thing. So you just tell all the information to the student. Okay. There will be companions. People say, oh, they're lonely. Well, you're going to have a chatbot who can talk to you all the time. Okay. And you can turn the switch to tell it to shut up. Okay, we're talking already the 5th subject, so we're good. We're close to 8. Autonomic and adaptive robots and drones. Robots and drones are in the same category. They're all machines. Okay, a robot walks along the earth. Okay, the drones fly. There's also under the ocean. There's also drones. All of that today is controlled by a human. Okay, whenever you're saying, okay, well, there's a drone that flew over the thing and killed a Iranian general. Well, guess what? All that is actually remotely controlled by a human somewhere else. But in the future, everything will be, the drone itself can fly over there and assess the ground situation and react to it by itself without having you to provide the information. Okay. So what's new is that the machine can learn by itself. You don't have to say, okay, well, I have a general robot, and now I want to have it do something else that originally you programmed it to do. Well, I'll cover more in detail next month, is that how do you train the robots? So that's another benefit of humanoid robots, is that we as a human, we can show, for instance, there's a picture that says, okay, a human is playing the drums, okay? And then once the human plays the drums, the robot can learn from the human because the robot is a humanoid. So whatever the person is doing, now the robot can learn from the human. You don't have to have another robot teach it, another robot. And remember the multimodal. You don't have to go and come up with the instruction to tell the robot how to play drums. Just show a video of a human playing drums. The robot captures the video, says, oh, that's the way you play it. You listen to the music, this is the way you touch it. Okay? Okay, so the three characteristics of this. One is autonomy. It can do it by itself. You don't need to have somebody else controlling it. Okay? So it's autonomy. Second one is that it can learn. So something that I did not know before, by observing, how do humans learn? When you have a baby or a kid, how do they learn? It just looks the eyes, they look around, say, oh, that's the way you do it. Oh, that's the way you do it. Okay, you look by observation. You learn by observation. So it's no longer going to be like a command driven. So this thing is going to go so fast that you won't believe it. Because once you do that type of learning, you can take the actual word of videos of the world and feed it to a machine, and the machine will learn. You don't need to know how to program. Okay, that's why there's, I think, I don't know, one of the CEOs said, you no longer need to be a software engineer. Okay, so anyway, an agency means that it has its own motivation. Why am I doing it this? It knows, okay? So I'm going to go faster. On this slide, basically, I want to say two things to capture from this slide. One is that there are new ways to learn. The robots can learn from watching humans do it. And then there's always new ways to teach. So in the past, the bottleneck was that how do you instruct the robot to do something? And that problem may be solved already. Because if the robot can learn from video, just feed the video. How to do it. You don't no longer know how do I tell the machine to do a certain task? So the other thing that is very interesting and very concerning is that the robots will be able to learn new things, just like we humans, whenever we say, okay, you go and listen to Bill, shoot the breeze here, for 1 hour. Say, oh, today I learned a little bit more about the constellation about satellites and so on. Okay. In the future, the robots can learn also by itself. Okay. And by that time, I'll be moving on to do something else. I'm no longer beginning seminars. Okay, so I'm done with basically today's 5 topics. So I'm right now 8 o'clock. I'm quickly going to go just spend 1 or 2 minutes just about what is in the horizon. What are things to watch? Everything that I'm covering, the next ones are more like a little bit more into the future. It's not like immediate, okay? Now, the other one is sort of concurrent. You know, you can say that we're actually living in the world of robots and so on right now, okay? In the satellite communications and drones and so on. One is that I gave a seminar last year on photonics. You know, why photonics? Because you know the speed of light is faster than speed of sound. So right now everything is fast. So you need to take advantage of the speed that the light travels is much faster than sound, right? So photonics is going to be the future. Everything will move to something that is really fast. New processor technology. So I've given many seminars already on quantum computing. You know, how does it require superconductivity, low temperatures, and all that stuff. Okay, so usually these topics rotate. So maybe every, let's say you have 7 or 8 different topics throughout the year. I'll give probably one talk about each of them. You know, every year and a half I'll be covering, coming back to give the updates on that. Okay, so new processor technology include quantum computing, edge computing. I think last week, actually, there was a talk on 2D semiconductors, okay, and things like that. So new processor technologies, processor meaning computing technologies. Okay, so I'm going to skip just for the time. Third one is the new IP. IP, not intellectual property, but internet protocols. So we need to have more standardization. So right now, everybody relies on the internet. Okay, so the internet will also evolve. So we're going from whatever internet 2.0 to 3.0. Okay. Also networking. Okay, right now we are in the decade of 5G. 5G is from year 2010 to from 2020 to 2030 is 5G. Okay. So, but people are already working on next generation, 6G. Okay. And the other thing that is going to be always with us, people ask me, what career should I go into? There are always a couple of perennials. One is new materials. So graphene sort of falls into that category. Okay, we don't know what is going to be replacing silicon, but graphene, carbon-related structures will probably be one. Because, you know, graphene has its own properties and characteristics. It's harder than steel, it's transparent. It has a lot of good properties. All of them are listed here. Impermeable, mechanical, electrical properties. It's faster, it's stronger. Okay. So anyway, I've given a talk on graphenes in the past already. So there's already material that's out there. Okay. So this is the last slide. So in this talk, we'll cover 5 different technologies, you know, from adaptable robots to secure computing to IoT and so on. And then we mentioned 5 additional ones. So the main motivation for tonight's talk is that we wanted to focus on something other than AI. So, you know, say besides AI, there's a lot of other technologies. So that was the purpose of tonight's talk. Okay. Now, preview of what's coming next month. Next month, for people who are immersed into AI, I'll be talking specifically about AI. Most recent developments in AI, full hour, okay? What is going to be covered in that talk? This is the agenda for next month's talk. So everybody heard about Sam Altman, that he got fired by OpenAI, and then he got reinstated and all that stuff? All of that is because of a technology called Q-Star. So what is Q-Star? I'll be talking about what is Q-Star. Okay, we heard about LLMs. All the LLMs are based on transformer architecture. But there's right now a more efficient architecture called Mamba. I'll be covering that. It's new stuff. Okay. There's a new type of AI. Is that how do you make sure that the AI sticks with regulation? It doesn't violate some ethical things. It's called constitutional AI. I'll also be covering that. All the latest that on a weekly basis, you know, figure 01, Tesla Optimus robot, there's so many new robots right now. Even NVIDIA just presented the 8 robots are standing with Jensen Huang on his GPU conference. Okay. All of that, depending on where I can procure this conference room. But right now it's scheduled for that. Okay, thank you for your attention. Hopefully you learned something today. And what I'll do is that first I'll open up for anybody here who have any questions or comments. Yes.
I have a question about I just looked it up really quickly, and it looks like it's based off of climate rooms and it's just like RSA overall. Those all kind of so that kind of operation is extremely expensive. So what is the scalable use case?
Yeah, okay. So I don't have enough slides to cover the specifics of homomorphic. The only advantage of that, and it may be, as you say, costly, right? Okay. So you also may not be there yet because a lot of the things I covered today, it's not like everything is already mature. That's it. Okay. By the way, tomorrow you can go and use the homomorphic. Okay. We're just saying that this is what the people are focusing in terms of making the data secure. Okay. Now, for all the more specifics, you are welcome to send me an email. I can give you more detailed, answer. Okay, or at least if I don't know the answer, I'll point you to some material that help you out.
Okay, and just a real quick question after that, to follow up to that. I mean, it's not a currently mature technology. It's also based on finite ideals like RSA optimal. Isn't it susceptible to factorization using Shor's algorithm and quantum computing?
Well, quantum computing, to tell you anything, when you mention quantum computing, is at least, well, we heard about, as a matter of fact, I didn't already talk on quantum computing. But quantum computing to be in our hands is at least 3 to 5 years away. Because it's too expensive. Right now, only a couple companies like IBM and Google, they have maybe you say, oh, well, we can do quantum computing.
Yeah, but my point is, if one is not mature,
right,
and quantum computing is not mature, if they mature in parallel, then one validate the other down the line.
I will not. Right now, this one thing I learned about doing all this trip. I don't want to give an answer for any subject matter that's more than 2 years away, because right now the speed of things, the way that things are changing. Okay, so people, when people used to talk, I said, can you give some predictions? Before they said, can you predict where things are going to be in 10 years? Right now, nobody asks about what's going to happen in 10 years because even 5 years, nobody knows. So right now, whenever I give an answer, it's something that I can see in the next 1 year or 1 to 2 years. There's something that will happen. Anything that is forecast to be, like for instance, even self-driving cars, I cannot give you a date because it may still be a couple years away. There are some technologies that are always 1 year away. And then when you reach that, oh, it's still yet another year away. Okay, so quantum computing and even homomorphic things, I would say right now they are just something that is on the horizon. People say, oh, if you want to go, for instance, let's say that you want to go, your interest is in encryption, okay? And you want to go and find a job in a startup that works on that. Okay, you say, oh, I'm aware that there's such a thing. So I'm interested in that. What are the companies that are working on that? That's the only thing, but I cannot tell you anything about when or what it will be. Because even if you, as a matter of fact, if you ask somebody who works on those companies, they will not be able to tell you. Right now, things are moving too fast. And everything is it's good to know that there's such a thing as an homomorphic computing. But who knows? The thing may die in 2 years. People say, well, it takes too much computation to do it. Just like encrypting, like Bitcoin. Oh, well, the people talk about blockchain and it takes forever. Blockchain today is still, it appeared probably 7 to 8 years ago. But today, how many people use it? Well, it takes still too much compute time to do it. Okay, so there's a thing also. One thing is to be able to say, okay, I'm interested in that because I'm interested in that area. I want to maybe find a career in that area. But in terms of affecting everybody here in this room, All those things are too far away. Okay, but thanks for your question. So, by the way, you see that I'm a Chinese. Usually Chinese are very conservative. I'm a little bit like in the middle because I've been in the US since I was 18. Okay. So there's one thing that I follow the way that Americans do. Whenever I don't know the answer, I'm not just trying, it's not like ChatGPT at the beginning. You just give you an answer. Okay. No matter whether the thing is true or not. Whenever I don't know, I'll tell you, sorry, I cannot help you because, or I don't have a valid information. But right now, because I'm retired, I read everything there is. And I have a certain opinion. If you ask me, I'll give you my opinion. My opinion doesn't necessarily have to be right, okay? But I'll be willing to share with it. And then also putting in fine print, say, by the way, if I don't know enough about it, because I don't work on homomorphic computation, I don't work for a company and start working on that. So all the details, I probably don't know about it enough, okay? I know that there's such a thing that people say, if you're working, because right now there's so many startups in Silicon Valley that are working on data security and privacy, right? That we know. And there are different ways to address the thing. But, a job is something that you go there, work from 9 to 5 or 8 to 5. And not everybody's, by the way, when people attend my seminars, there are a lot of people from Google, from Meta that come and listen to my talks. Why? Because when they work for those companies, they're immersed in the lab and they're immersed in doing their programming, but they don't have the global perspective that I have. Okay. Okay, so let me see. I don't know where anybody is manning the chats. Let me see where I can find where there's any questions on chat. Okay, right now I don't have any questions from the chat. By the way, you are welcome to ask any questions, even on besides the topics that we covered today. There are companies working on MEO. Right now, for instance, in that slide that says Leo, MEO, and Geo, there are companies working on each of them. And because each of them, they have different motivation. Like for instance, in the MEO, GPS is that we use every day. That's under MEO. So the ones that we use the most, actually, everyone here uses is GPS. Whenever you are in the middle, you're saying, okay, right now I'm sitting in Montague and whatever. So, okay, I want to go home. Okay, you use GPS, right? And then China has its own polar, the polar GPS. They have their own version because they once tried to use GPS. There's a ship in the middle of the ocean, and suddenly they could not go anywhere because they shut down the GPS. So the ship was sitting in the middle of the ocean, don't know where to go. Okay, so it's very important. So that's the reason why China developed their polar navigation system. So there are 5 different navigation systems. Most of them are in the MEO. So if you look at Leo, if you look at the picture at night, there's so many. Every few miles, there's one. There's too many. So each system has maybe around 1,000. Some is actually more like 800, something around that, around the whole globe. Okay, that's too many. Because in order to send all the satellite to orbit, you have to send a rocket. So only Amazon, the Cooper, that's the Jeff Bezos outfit, and then there's Elon Musk, Starlink, because he owns all the rockets. He can send every month 80 satellites, but it's very expensive. So all the other ones, they send one satellite. The GEO, because that's far away, but you need probably only 2 satellites to control any area of Earth. One is on one side and that one is on the reverse side, or maybe 2 to 3. Oh, by the way, so that's a good point. That's a good point. So reliability is an issue. Do you know that once you set up the constellation, once in a while you have to service because some of the satellites will get too old and they'll fall back into Earth. And then you have to send another satellite to replace that one in that position. Yeah, there I can tell you for 1 hour or a couple hours on everything about satellites. Because I used to give a very special, there's that called killer satellites. Okay, so you have satellites, right? So they all have a function. So whenever there's like countries, they can send you a satellite that will shoot down a certain satellite. So that whenever you have that, then you have a vacuum in that area. Okay, so you can block something. As a matter of fact, I wouldn't be surprised that. Do you know that the U.S. has now a special force called the satellite, I don't know, called space force, okay? So that is to cover because right now, whenever you are in space, when the other country is firing a rocket up, you can already see it in space. So you want to shoot it down. You don't want to wait for it to already come back to the atmosphere. You have to shoot it while it's still in the air, or you have to disable it. So right now, there's a lot of things that are being worked for sure. It's not that some of them is probably not in the public domain. For instance, whenever there's a satellite, there's also killer satellites that the function, as a matter of fact, there's a lot of James Bond movie that send the thing that said just to shoot down somebody else's satellite, right? So
why does a satellite fall into the ocean? Why can't it stay in orbit?
Because e-waste. Do you know that there's thousands of broken satellites that are in outer space? So there's one startup that you can go that I recommend you to do because nobody has done it yet. Is to garbage collecting in space. Because there are so many satellites that are broken that they're not functioning. They're sitting there. And then one day, as a matter of fact, there's a picture of all thousands of satellites that no longer work, but they're still floating there. So how do you, because you cannot have like a waste, like a dump in space with all the pieces of satellite around the planet Earth. So one day, just like before, if you hear some of the news is that a lot of people used to dump garbage and they suddenly everything, they are parts of the ocean, it's all full of garbage because they're all plastic bags. They don't dissolve. So one day there's a company that will go and just do that, make money out of just getting all the garbage from the ocean. Well, the same thing is going to be in space. So for everything, there's also a new opportunity. Okay, just like I was describing, in my house, in my desk drawers, there's so many old phones that no longer work. And I don't know why I'm not just throwing into the garbage, but maybe I'm afraid that somebody will pick it up and extract some information from my cell phone. Okay, but all that is called e-waste. It's electronic related waste. Okay, so satellites, the same thing. Thank you for those very, very good questions. I mean, there for every subject matter, if you really want to deal with that one, you have to look at the whole enchilada. You have to know what are the pros, what are the cons, what are the challenges, what are opportunities, what are the liabilities. That's why when I give talks here, a lot of people come and listen. They are experts in AI, but why do they come to listen to Bill talk about Q-star or whatever? Because I also be able to share with you what I think about it. Okay. It doesn't mean that we have to agree on everything. I may have an opinion. I'll let you know my view. You can agree with it, you can disagree with it, doesn't matter, because I don't charge anything. So, where you are, if you listen to me and say, okay, well, this is the rationale why Bill is thinking this way. And your motivation may be different, right? But it's good to always hear other people's opinions. So that's why right now I'm retired. I watch everything that is in YouTube. I watch what Jensen Huang says. I watch what Lisa Su says. What Elon Musk says. What the politicians say. what the marketing people say, what the users say. I listen to everybody. I say, okay, well, that's his perspective, or that's his angle. Okay, so anyway, I think we're close to 8:30. Again, thanks for coming. If you are really interested in AI, come to next month because you're going to hear a lot more detail about Q-Star, about Mamba, okay, about all the new humanoid robots, okay, and so on. Okay, but again, thank you everybody for coming here tonight, as well as all the people attending via Zoom. Okay.